Okay guys, we're doing chapter 2.7, graphing techniques. The main tip I have for you on this is whenever you're in doubt on how to graph a function, remember like y equals f of x, where f of x, let's say, equals 2x squared. So you're going to be working with this problem here, y equals 2x squared. If you had a question or any kind of doubt, you don't even know where to begin here, always start with a little table like this, and just pick some easy numbers to work with. And these are the three numbers that I always choose. I think I mentioned this last section as well, but just use these three numbers to plug in for x. So 1 squared is 1, 1 times 2 is 2. 0 squared is 0, 0 times 2 is 0. Negative 1 squared is 1, 1 times 2 is 2 again. So you've got these 3 points here. I guess I should have put that on the other side. You can write them in an ordered pair like such. And we could graph those. So a graph like that would look something like this. 1, 2. The pen's not working. 0, 0. Negative 1, 2. So we've got those 3 points. And we also know that x squared, that's a parabola. So this isn't going to be a V, where you just connect the dots. It's going to be a little bit more like a U, like where it's got a bend in it, as opposed to a straight line from point to point. Something like that. And you're going to know that just from a previous section where we talked about x squared, basic functions and how their graphs look. So that's what I would do there. Now let's move on to the next example. Again, if you don't know what it's going to look like off the top of your head, just pick a few numbers. With your same little table here, it's pretty simple, pretty straightforward. 1, 0, negative 1. You could even, instead of just choosing 3, if you wanted a little bit more of an idea, choose a couple more numbers. And I always just choose small numbers like this, just so it's easier to work with. So plugging these in for the x value. 1 squared, 1 times 1/2 is going to be a half. Plugging in the 0, you're going to get a 0. Plugging in the negative 1, you're just going to get positive 1/2 again. Plugging in the 2, 2 squared is 4. 4 times 1/2 is 2. Negative 2 squared is 4. Again, same thing, going to be 2. So we go ahead and plot these points. I don't think I need to write them out in ordered pair again. You guys did pretty well on that last homework. So we'll do, here's 1. So here's negative 1. Here's 1. 0, 0. 2, 2. Okay, we got negative 1.5. We got negative 2 and 2. So that's not a very even. Here, let me scoot this in a little closer so it's a little bit more symmetric. There we go, that looks a little better. So now, again, we're dealing with an x squared, so it's going to be in a parabola. So they're not going to be connecting the dots, it's going to be more of a U, like such. And you can see these two here, they look pretty close or pretty similar, but if you drew them to scale a little bit better than I had, you would see that this one is a little bit wider than this one over here. So this one is pretty skinny. And what that's going to tell you is it's simply going to climb a lot faster. And if you think about it, as you choose, let's say 2, well, 2 squared, that's 4, and 4 times 2, that's going to be 8. So your next point is like way up here at 8. And your value of 2 here going into x, that's only at 2. So you can see that this one here is skinny, it's skinnier, so therefore your y values are going to be higher as you run your numbers through it, like we just did. Also, let's do one more example. We had g of x is equal to 1/4 x squared. Do it again, just do your xy chart. Let's plug in the same numbers. I always do these, 0, 1, -1. Just stick with a 2 and a -2 again. As you plug in 0, you're going to get 0 back. As you plug in 1, 1 squared is 1, 1 times 1/4 is 1/4. Same thing with -1. For 2 and -2, you're actually just going to get, well, 2 squared is 4, and 4 times 1/4, that's just going to be 1. So, same thing for both of them. Again, you just plot these, so we've got 0, 0. We've got 1 and -1, and that's going to be at a 4. And then at 2 and -2, that's going to be at 1. So here's 1. And this one is actually going to be even wider than that one. So since it's wider than this one over here, it'll definitely be wider than the one over here. So what can we draw from, what conclusion can we say from these three graphs here? Well, we know we have this function, this one, and this one. And the one thing that we see that's the same is they all have x squared with them. The only thing that's different is the coefficient that's out in front of them. And that coefficient, let's go ahead and just call it a. So if a is greater than 1, this will be considered vertical stretching of your graph. Vertical stretching. And so then look at this one again. As you can recall, this one's graph is going to go almost straight up, just because it's kind of going to be stretched vertically. So as we look at x being 2, your y value is going to be 8. As you look at x being 3, well, 3 squared is 9. 9 times 2 is 18. So that's even further up there, of course. So it's going to climb the y-axis a lot faster, therefore stretching your graph. These two here, we had the coefficient in front of x squared as a half and a fourth, so therefore it's less than 1 but greater than 0. So if a was less than 1 and greater than 0, this one would be more of a vertical shrinking. Vertical shrinking. And you know, as we said over here, with this function, as you plug in 1, you're going to end up getting 1/2. As you plug in 2, you're just getting 1. And then coming back over here, as you plug in 1, you get a fourth, and as you plug in 2, you get 1 again. So it's not climbing the y-axis near as fast. And the closer you get to, or the smaller coefficient out in front you have, the slower it's going to climb the y-axis.